Let's continue the question in this video, and before we go on with solving this inequality, let's understand which graph we're going to use, because this is going to help us to see which expected utility is going to be lower under which policy. Now recall that our utility function is concave, so that's how a utility function that has a concave shape looks like, right? It is increasing at a decreasing rate. Now what we need here is to understand that there's going to be different utility levels for different income levels. So the best case scenario is when we keep all the income, right? For the full income level Y, we have a certain utility. We will have to keep in mind the first policy when we must pay $100, right? Meaning that our income decreases by $100, and that would be our utility from it, right, corresponding on the blue curve. And under the second policy we would pay $200, so that would be the utility belonging to this point over here. The reason we will see this on the graph is because we will see which expected utility is going to be higher in the end. So let's see how that works out. Now over here to solve this expression, it would be wise to take the common terms on one side. And what common terms do we have here? Well, we have utility of b and y. That's the same term with a coefficient of 0.8, and on this side we have that same term with a coefficient of 0.9. So let's transfer this over there. Let's transfer this one over there. What would we have as a result? Well, we are left with the first term of this entire thing. That's let me just write like that, 0.2 times the utility of b, and we have y minus 100, so we keep that. And on the other side we take 0.8 with a negative sign, and what are we left with? Well, we will have 0.9 minus 0.8, that's just 0.1 times this common term, which is the utility of the benefit and the income, and we also have this remaining term plus 0.1 times the utility of b and y minus 200. Hope this makes sense. Now, what else can we do here? Well, we have one more common term, and the common term that we have now is 0.1. 0.1 is here, 0.1 is here, and 0.2 is equal to 2 times 0.1. So let's write it like that. 2 times 0.1 multiplied with the utility of b y minus 100. And on the other side we will take 0.1 as a common factor, so let's write 0.1 as a common factor over here. And what are we left in brackets? Well, we have this term, the utility of by, the utility of b and y, plus the other utility, the utility of b and y minus 200. So the utility of b and y minus 200. Okay. We got that. What can we do now? We can cancel out something. So we can cancel out the 0.1 on both sides, right? We cancel out them like that. Now what we're going to do is we're going to divide both sides by 2 so that we can get rid of this 2. What do we have as a result? Well, we will have the utility of, I'm just going to show that we're dividing that by 2 as well. So the utility of b y minus 100, and on this side we have, let me just change colors, and this side we will have the utility of by plus the utility of b and y minus 200 divided by 2. Now our graph is going to be handy. First of all, let's see that we have a common thing here. We have a certain utility from throwing litter, or littering, right? Throwing the trash. So we have utility of b in both terms, meaning that we don't keep that into account, like it's constant, it's in both cases. That effect is not important to us. What we want to know is the remaining utility, the utility that we have left from the money in our pocket after we pay the fine. That's what we're interested in. Again, the utility from the littering is the same, so there is no difference between them, but the utility from different income levels is different, because that's what we're going to see on the graph. What is the utility of y minus 100? Well, let's see. The utility of y minus 100 over here is this purple point, the utility of y minus 100. This one over here, this one. Now, what we're looking for is the utility of y minus 200, right? This one, the utility of y minus 200 plus the utility of y divided by 2. And this is where a bit of, I don't know how you call this, geometry, I think, is how can we calculate the midpoint between 2 points on the graph. That's what it is. The utility of y is here. The utility of y minus 200 is over here, the white point. When we divide it by 2, we must find out the middle point, the midpoint, on the line that connects these two. I think that's called a secant line. I'm not sure exactly, I forgot geometry. But it's this line like that. This is gonna be it, you see? And the middle point is in between these two. So it's going to be somewhere on that line, somewhere over here, for instance. That would be the midpoint. What can we see? That midpoint, that division that we just did, the utility, let me just write like that, utility of y plus utility of y minus 200 divided by 2, that green point is less than the utility of y minus 100, right? We graphically can see that that's less than the utility of y minus 100, and that's because of the shape of the graph, because of this concave shape, meaning that this expression over here that we just saw is going to be greater than the other one, right? The utility of y minus 100 is going to be greater than that middle point on the secant line. In other words, what can we see here is that the expected utility from the first policy, because that's what we compared so far. We did all these things to see which one has a higher expected utility. Well, the first expression was the first expression is the expected utility from the first policy. The other one is the expected utility from the second policy, and we just saw and we proved that the expected utility from the first policy is greater, meaning that the expected utility of the second policy is lower, such that the second policy for this utility function would be more effective to reduce littering, because the consumer would keep in mind that his expected utility would be lower, so he would reduce littering. This would be more effective to reduce littering because expected utility is lower. Anyway, hope this all makes sense, and we are done.